Okay, so in this short little video we're going to be looking at how to calculate the interior and exterior angles of a regular polygon. Okay, it's really important that we are focusing on that word regular polygon. Okay, all the sides are of equal length and all interior angles are equal. Okay, so what we're looking at are these shapes here, where all of the interior angles are exactly the same. Okay, so let's start looking on how we calculate the interior angle. Okay, for interior angles, there are two steps. What we've got to do is, I've written this here, is n is the number of sides. So what we've got here, if we look at this shape, you can identify that as a hexagon. It's got 6 sides. So to work out the interior angle of a polygon, what you've got to do to start, step 1, is you do the number of sides, take away 2. Okay, I'm going to put that in brackets because that's really important, and you multiply it by 180. Okay, if we use our example here of the hexagon, so what we'd have is 6 sides, take away 2, times 180. Okay, so that is 4 times 180. You can use a calculator, you can do it in your head, and that comes to 720. So what you've got is the total interior angles all added together, so the sum of them comes to 720. So the sum of our interior angles just for this shape is 720. Remember, it's going to change then depending on the number of sides of the polygon you're looking at. Now in step 2, what you've got is 720 is the total of the interior angles. We just want to work out how much one interior angle is. So what we've got here is, what you've got to do is you've got to do the sum of the interior angles, and then you've got to divide that by n, so the number of sides. So for our hexagon, it'd be 720 divided by 6, so it'd come to each of the interior angles is going to be 120 degrees. Okay, so if I was going to sum up those two steps in one go, the first step is n take away 2, so the number of sides take away 2 times 180. That will give you the total interior angles, and then to get the single interior angle, you've got to make sure you divide that by n. Okay, so those are the two steps into one formula. For exterior angles, the first thing I want to do is make sure everyone knows how to calculate an exterior angle. On the previous page, what you've seen is how to calculate the interior angle. You are going to need that to calculate the exterior. So if we focus on our example of our hexagon, we worked out that the interior angle is 120 degrees. Right, for the interior angle, what we've got to look at is, if that's our straight line, we know now for a straight line, all of the angles have got to add up to 180. So our exterior angle is this angle here. It's our missing angle on that straight line. So our exterior angle here is 60 degrees. Okay, so it's really important. Step 1, you know how to calculate the interior angle. And step 2, remembering it is on that straight line. What is that missing angle then? So here's the rule that you need to make sure you know. The sum of the exterior angles equals 360. It can't be any lower, it can't be any higher, it has to equal 360. So if we look at our hexagon as well, let's just double check that. The exterior angle is 60 degrees. You've got 6 exterior angles. 60 times 6 is 360. So we know that's correct. So this is an exam style question they could ask you. It could be worth 3 marks, and it's asking you how to prove if 80 degree could be an exterior angle of a regular polygon. So we know now that the number of sides times the exterior angle should equal 360. So what we've got is the number of sides multiplied by 80 should equal 360. We've set up our equation here, so let's try rearranging it to find the value of n. So what is the opposite of multiplying by 80? Is dividing by 80. So what you've got is 360 divided by 80, which comes out as 4.5. Because it is a decimal, that means it cannot be a regular polygon. So any polygon that's got an exterior angle of 80 can't be a regular polygon. So if n is equal to a positive whole integer, so a whole number, then what you've got is a polygon that can have that exterior angle. If the integer, or if n comes out as a decimal, okay, that proves it can't be a regular polygon.